A factory in Shanghai is making jet fuel out of air, not natural gas, not crude oil pumped from a well. Air, the same air you're breathing right now. A machine pulls carbon dioxide from the sky. Another machine splits water into hydrogen using sunlight. And when you combine those two ingredients under the right conditions, what comes out the other end is kerosene. Real, burnable, ready-to-fly jet fuel. A plane engine can't tell the difference between this stuff and fuel that took millions of years to form underground. Down to the last molecule, it's identical. That alone would be a headline in any other decade. A machine that makes jet fuel from air and sunlight. A technology that turns the atmosphere's biggest pollutant into the aviation industry's primary product. In any other context, that's the whole story. But it's not the breakthrough. The breakthrough is what happens when you connect that factory to 5 other technologies that China is building at the same time, in the same country, feeding into the same system. Separately, each one is impressive. Together, they form something no nation on Earth has ever had before. A complete loop that turns air and water into fuel, power, fertilizer, and industrial chemicals. No oil, no gas, nothing dug out of the ground, nothing shipped across an ocean. And that last part, nothing shipped across an ocean, is the detail that explains everything else in this video. Because this isn't a science project. It's a survival plan. And to understand why, you need to know about one narrow strip of water that keeps China's leaders awake at night. Between Malaysia and Indonesia, there's a passage called the Strait of Malacca. At its narrowest point, it's less than 3 kilometers wide. Picture a hallway. Now picture that roughly 1 out of every 4 barrels of oil traded on the planet has to walk through that hallway every single day. Tankers line up like cars in a single-lane tunnel, inching through one of the most congested shipping corridors on Earth. China imports more than 70% of its oil. Most of it passes through that strait. Every barrel, every day, every factory running, every airplane flying, every truck on the road depends on fuel that had to squeeze through a gap you could almost see across on a clear day. Military strategists have a name for this. They call it the Malacca Dilemma. And it's not theoretical. In 2021, a single container ship got stuck sideways in the Suez Canal, a different choke point entirely, and within days, global supply chains started breaking. That was one ship in one canal for 6 days. Now imagine what happens if the Malacca Strait gets blocked. Not by accident. On purpose. Factories across China grind to a halt. Prices spike overnight. Store shelves empty. Gas stations run dry. And because factories worldwide depend on parts flowing through Chinese supply chains, the damage wouldn't stay inside China. It would ripple across every continent within weeks. China has tried to build around this for years. Pipelines through Central Asia, deep water ports in Pakistan and Myanmar, underground reserves buried beneath the desert holding months of emergency supply. None of it solved the core problem. The oil still has to cross water to reach any of those workarounds. A pipeline from Pakistan to Western China helps, but the oil has to reach Pakistan by ship first. A reserve tank buys you time, but eventually it runs dry. So what if the oil didn't have to travel at all? What if you could make fuel exactly where you need it, out of ingredients that are already everywhere? That question is what built every single technology in this video. And the factory in Shanghai is where the answer starts becoming real. The company is called Carbonology. It opened in January 2026 in Shanghai's Lingang district. The process sounds almost too simple when you break it down. Step 1. A direct air capture unit pulls carbon dioxide straight from the atmosphere. The same gas that comes out of car exhaust, the same gas trapping heat in the atmosphere and warming the planet. Instead of letting it cause problems, this machine grabs it. Step 2. Solar panels power an electrolyzer that splits ordinary water into oxygen and hydrogen. The oxygen gets released. The hydrogen gets kept. Remember that word. Hydrogen. It's going to keep showing up. Step 3. The captured carbon dioxide and the hydrogen get combined under heat and pressure. The molecules rearrange. What comes out is a synthetic liquid fuel that is chemically identical to conventional kerosene. Not similar. Not close. Identical. A pilot wouldn't know the difference unless someone told them where the fuel came from. Right now, the plant produces about 100 tons per year. That's a demonstration scale, enough to prove the chemistry works outside a laboratory. But the roadmap moves fast. A 1,000-ton plant is next. Then 5,000. Then a full commercial facility targeting 100,000 tons per year by 2027. To put that number in context, 100,000 tons of jet fuel powers thousands of trans-Pacific flights. Investors noticed. Sequoia China and the Yellow River Delta Investment Fund both put real money behind it. These aren't people who chase hype. They study energy economics for a living. When they write a check, it usually means the math works. And the timing isn't accidental. European regulations now require airlines to blend a percentage of sustainable aviation fuel into their supply starting this year. That percentage grows aggressively by 2050. Airlines that can't meet the requirement face penalties, which means the buyers aren't choosing to line up. They're legally required to. The demand was written into law before the supply even existed. That almost never happens in any industry. Normally, you build the product and hope people buy it. Here, the customers were guaranteed by regulation before the factory finished scaling. Carbonology walked into a market that was already waiting for them with purchase orders. But fuel from air solves only one piece of the puzzle. There's a harder problem hiding behind it. One that has nothing to do with what you burn and everything to do with when the power is available. Because the sun doesn't cooperate with factory schedules. And what China built to fix that problem is one of the strangest power plants you'll ever hear about. In the Gobi Desert, engineers took ordinary air and froze it. That's the entire concept. They cool air down to roughly negative 194 degrees Celsius. At that temperature, air stops being a gas. It becomes a liquid. You can pour it into insulated tanks and store it like water in a reservoir. It sits there quietly, holding all that compressed potential energy, waiting. When the grid needs power, they let the liquid air warm up. As it warms, it turns back into gas. And when it expands, it doesn't expand a little. It expands 750 times its liquid volume. Imagine a coffee cup of liquid suddenly filling an entire room with pressurized gas. That violent expansion spins turbines, and those turbines generate electricity. The facility sits in one of the harshest landscapes in China, the Gobi Desert. Extreme temperatures, relentless sun, almost no rainfall. It sounds like the worst place to build anything. It's actually perfect. A 250-megawatt solar farm sits next door, generating enormous amounts of electricity during the day, far more than the local grid can absorb. Normally, that excess power gets wasted. Curtailed is the industry term. The panels keep producing, but the energy has nowhere to go. Instead, this facility uses that surplus to freeze more air. At night, when the solar farm goes dark and the grid starts drawing down, the frozen air converts back into electricity and keeps power flowing for 10 straight hours. 10 hours. The best lithium battery farms in the world tap out around 4 or 5. This doubles that. And it does it without any of the supply chain headaches that make batteries so complicated. And here's what makes this different from batteries in a way that matters for the bigger picture. No lithium, no cobalt, no rare earth minerals that have to be mined in one country, processed in another, and assembled in a third. Just air, cold temperatures, and industrial equipment. The raw materials are literally everywhere. The facility has been operational since late 2025, producing roughly 180 gigawatt hours per year. That's not a prototype anymore. That's a working power plant. So you've got fuel from air and power storage from frozen air. But some machines can't run on electricity at all. Cargo ships, for instance. The global shipping fleet burns heavy fuel oil, the dirtiest, thickest petroleum product there is. Ships move about 90% of everything traded on the planet. If you want to disconnect from oil, you have to solve shipping. And the answer to that came from a molecule most people only know from cleaning supplies. Ammonia. Simple, boring, industrial ammonia. Here's why it matters. Hydrogen, that word again, is an incredible clean fuel. Burn it, and the only byproduct is water vapor. Nothing dirty, nothing harmful. But hydrogen has a brutal practical problem. It's the lightest element in the universe. Moving it in useful quantities means either compressing it to extreme pressures or cooling it to extreme temperatures, both of which are expensive and difficult at scale. Shipping hydrogen across an ocean in those conditions is like trying to mail a balloon. Ammonia fixes this. You pack hydrogen atoms into ammonia molecules. Ammonia is a stable liquid at modest pressures. You can ship it in ordinary tankers across any ocean. When it arrives, you extract the hydrogen and use it. Ammonia works like a lunchbox for clean energy. Pack it, ship it, unpack it. Traditionally, making ammonia requires enormous heat, crushing pressure, and natural gas. The Haber-Bosch process has been doing it that way for over a century. It's one of the single largest consumers of natural gas on the planet, responsible for roughly 1 to 2% of global energy consumption all by itself. And the reason nobody talks about replacing it is because ammonia is the backbone of fertilizer production. Half the world's food supply depends on it. Without ammonia-based fertilizer, billions of people go hungry. You can't just stop making it. You have to find a cleaner way to make the same molecule. But in Shanxi province, a plant is now producing ammonia without any of that. No natural gas, no fossil fuels, just nitrogen pulled from the air and hydrogen made from water using solar-powered electrolysis. Room temperature. The plant has run continuously for over 50 days at above 90% efficiency. That's not a laboratory curiosity. That's a production line running real shifts. Japan and South Korea are already testing ammonia-powered cargo ships on real ocean routes with real cargo. Not simulations, not scale models in a tank. Full-size vessels burning ammonia instead of heavy fuel oil on actual commercial shipping lanes. If the shipping industry shifts to ammonia as its primary fuel, the oil that currently powers those vessels stops being necessary. Not cheaper, not reduced, optional. That single word, optional, changes the entire equation. Because the shipping industry doesn't burn a little oil. It burns roughly 5 million barrels a day. Remove that demand and the economics of the entire global oil market shift underneath everyone's feet. Now step back and look at what's accumulating. Jet fuel from air. Electricity storage from frozen air. Clean ammonia from sunlight. 3 different technologies solving 3 different problems. But there's a thread running through every single one of them. And once you see it, the whole picture snaps into focus. Hydrogen. Every breakthrough we've talked about needs it. The synthetic jet fuel process needs hydrogen to build fuel molecules. The liquid air storage runs on clean electricity, and hydrogen-generated power feeds into that grid. The ammonia plant uses hydrogen as its primary input. Hydrogen isn't one piece of this puzzle. It's the piece that connects every other piece. It's the universal ingredient. So the real question becomes, how much hydrogen can one country actually produce? And the answer is moving faster than almost anyone expected. In 2019, China produced about 23,000 tons of clean hydrogen per year. By 2024, that number hit 125,000 tons, almost 6 times more in 5 years. To understand how unusual that growth rate is, consider this. Most new energy technologies take decades to scale by that factor. Solar power took nearly 30 years to achieve a similar multiplier. Wind took over 20. Hydrogen did it in 5. That doesn't happen organically. It happens when a government decides something is strategic, puts billions behind it, and treats it with the same urgency as a military program. One province alone, Guangdong, is building a massive offshore wind farm whose sole purpose is powering electrolyzers that split water into hydrogen. That single project targets 80,000 tons per year. One province, one project, nearly as much as the entire country was producing just a few years earlier. But the number that matters most isn't how much hydrogen China makes. It's this one. China now manufactures roughly 65 out of every 100 electrolyzers sold worldwide. Electrolyzers are the machines that split water into hydrogen. They're the critical hardware in this entire system. Whoever builds that machine controls how fast the energy transition happens. Not just at home, everywhere. If a country in South America wants clean hydrogen, it needs electrolyzers. If a nation in Africa wants a green ammonia plant, it needs electrolyzers. If a European airline wants synthetic jet fuel, the process starts with an electrolyzer. And most of those machines will come from one country. The government formalized this by making hydrogen part of national energy law. Same legal status as oil and gas. Real funding behind it. Billions of yuan committed. Not as a research initiative. As infrastructure. Even the old oil companies can read the direction. One of China's largest petroleum refiners saw its profits drop by more than a third in 2025. Not because people stopped needing energy. Not because demand collapsed. Because alternatives started competing on price and performance for the first time. Their response was the most revealing signal of all. Instead of fighting the shift, they committed nearly 800 million yuan to converting one of their existing fuel refineries into a synthetic jet fuel plant. A company that was literally built on oil, whose entire identity and infrastructure was designed to process crude petroleum, looked at the next 20 years and decided its best move was to stop being an oil company. When the incumbents start switching sides, the transition isn't coming. It's already here. But there's still one more piece. The one that makes everything else look like a warm-up. Every technology we've covered still depends on an energy source that comes and goes. Solar needs sunlight. Wind needs wind. Storage systems are clever workarounds, but they're still working around the fact that supply isn't constant. What if there was a source that never stopped? Day and night, summer and winter, rain or shine. Constant, limitless power from a process that uses hydrogen from water as its fuel. A process that produces no carbon emissions, no dangerous waste, and could run for centuries on the hydrogen in a single lake. There's only one technology that fits that description. Fusion. The same process that powers the sun. The basic idea is deceptively simple. Take 2 hydrogen atoms. Force them together at extreme temperature, hotter than the center of the sun. When they fuse, they release an enormous burst of energy. No harmful gas. No long-lived radioactive waste. And the fuel comes from water. China's primary fusion machine is called East. Experimental Advanced Superconducting Tokamak. It's a massive donut-shaped chamber lined with superconducting magnets that hold a cloud of superheated plasma in place while fusion reactions occur inside it. This year, East hit a milestone that no other machine on the planet has matched. It held a stable fusion reaction longer than any previous attempt anywhere in the world. The plasma inside the chamber reached temperatures exceeding 120 million degrees Celsius. That's roughly 8 times hotter than the core of the sun. And it held that state long enough to push past what physicists call the Greenwald density limit, a theoretical barrier on how much fuel you can pack into the plasma before it destabilizes. For years, that limit was treated as a wall. East pushed through it and kept running. The engineering required to do this is almost impossible to overstate. You're containing a gas hotter than anything in the solar system inside a machine, using magnetic fields so precisely calibrated that the slightest fluctuation would end the reaction instantly. And they held it stable, not for a flash, for a sustained, record-breaking run. Fusion isn't ready for your wall socket yet. Anyone who tells you otherwise is selling something. It's still years from commercial deployment. But the trajectory is clear, the funding is massive, and each milestone brings the timeline forward. And here's why fusion is the piece that ties this entire video together. Every single breakthrough we've discussed becomes exponentially more powerful once you pair it with a limitless supply of clean electricity. Synthetic fuel factories could scale without constraint. Hydrogen production becomes virtually unlimited. Ammonia plants run around the clock feeding global shipping and agriculture. Liquid air storage becomes a buffer for a grid that never actually runs low because the power feeding it never stops. Put it all together, and you get something that has never existed before. A closed loop. Air and water go in. Fuel, power, fertilizer, and industrial chemicals come out. Nothing mined. Nothing drilled. Nothing shipped through a 3-kilometer choke point that someone else could close tomorrow. That's not an energy strategy. That's energy independence. Real, total, structural independence from the geography of fossil fuels. The kind of independence that no amount of aircraft carriers or pipeline deals or emergency reserves could ever provide. Because you can't blockade air. You can't sanction water. You can't embargo sunlight. For over a century, power in the world meant controlling oil, or controlling the routes oil traveled through. The Strait of Malacca, the Persian Gulf, pipelines through Central Asia. Geography was destiny. Whoever sat on the deposits held the cards. Whoever controlled the shipping lanes dictated the terms. The map itself was power. But if you can make energy anywhere using ingredients found everywhere, that old kind of power starts to dissolve. It won't be about who owns the oil field. It'll be about who builds the machines that make energy from nothing. The reserves stop matching. The choke points stop being strategic. And the country that builds and exports those machines becomes the one with real influence. China already makes 65% of the world's solar panels. It dominates electrolyzer manufacturing. It controls the production of the batteries, the turbines, the infrastructure hardware that the new energy economy runs on. It's exporting the machinery of the new energy system the same way oil-producing nations once exported barrels. The product is different. The logic is identical. And the countries buying those machines are building their energy futures on Chinese hardware the same way they once built them on Middle Eastern oil. The dependency doesn't disappear. It moves. This isn't a forecast. It's already happening. Fuel plants are under construction. Hydrogen output is multiplying. Refineries are being rebuilt around synthetic inputs. Construction sites with cranes and concrete, not slides in a conference room. The world that ran on oil didn't announce its own ending. It just started losing ground to something faster, cleaner, and impossible to blockade. One facility at a time. One technology at a time. One country building the machines while everyone else is still debating whether the transition is real. A factory in Shanghai is turning air into jet fuel. A plant in the Gobi Desert is freezing air into electricity. A facility in Shanxi is making rocket fuel ingredients from sunlight and water. And somewhere in a donut-shaped chamber in eastern China, hydrogen atoms are being forced together at 120 million degrees, inching closer to the moment when the last piece clicks into place and the loop closes for good. Which part of this surprised you most? The fuel made from air, the frozen air power plant, or the fact that one country now builds most of the machines the rest of the world will need to make this transition? Tell me in the comments. If this gave you something new to think about, subscribe to Tech Unwired for more. No hype, no fluff, just tech that actually matters. The next video connects even more dots you probably haven't seen yet.